Our last speaker for this morning session is Jochen Korgor, Vice President of Global Marketing at Everlight, and he's going to discuss new prospects of LED and market applications. Mr. Korgor 在光电 LED 产业及固态照明领域已经有了20多年资历，具备市场研究、产品开发及业务行销的工作经验。今天 Mr. Korgor 将要和我们探讨的是 LED 照明终端市场的最新市场应用。Ladies and gentlemen, let us welcome Mr. Korgor.
Good morning. Thank you very much for your time. I know you are all hungry, so I will go quickly. I am the Vice President of Global Marketing for Everlight. The topic of the talk is new prospects of LED and market applications, but the talk actually focuses on one thing, and that is the light bulb. As my responsibility in Everlight is to run the business units. Hence, I have revenue responsibility. So, from a commercial point of view, there are two things that I am really interested in. One, how can I sell more light bulbs? Two, can I make money by doing so? So, this is really the focus of this talk this morning. First, I will give a very brief overview of Everlight for those who are not familiar with Everlight. Then I will talk about LED lighting versus other energy efficient alternatives, because really the competition for LED lighting is not the incandescent bulb, it is really other energy efficient alternatives from a market perspective. Finally, I will give an update on LED lighting adoption. I actually mentioned this in the last LED Forum seminar, but I would like to give you an update, and finally the conclusions. First, about Everlight. Everlight was founded in 1983. It is a publicly listed company since 1997. We are in the business of designing, manufacturing, and marketing of optoelectronic components and systems. We're based in Taiwan. We have global locations, over 15 locations globally, 6,400 employees worldwide, and 3 factories, 1 in Taiwan, 2 in mainland China. Our average monthly capacity is about 2.4 billion LEDs per month. That makes us one of the largest LED producers in the world. So that's Everlight. Let me move on now. I think everybody is familiar that we can save energy by using LED as a lighting component to make a light source. This is valid for when we compare it with incandescent lamp. For example, a 40 watt could be replaced by a nominal 5 watt LED bulb. Same for if we compare it with linear fluorescent, a T8 fixture, and for outdoor lighting or area lighting as well. If we do a very quick comparison with other energy saving alternatives, as I mentioned, incandescent is one source, but really linear fluorescent and compact fluorescent are other sources that LED is competing against. And we can have an LED lamp retrofit, replacement lamp, with better than 70 lumen per watt efficacy today. Actually, there are reports of efficacies much higher than that. In fluorescent, linear fluorescent, about 60 to 80 lumen per watt. This is more for T12 and T8. There are new T5 lamps that have higher efficacies. And finally, with CFL, about 50 to 70 lumen per watt. And we can compare the lifetimes. LED has a long lifetime, or expected to have long lifetime. Recently, certain linear fluorescent T5 products actually offer longer than 20,000 hours as well. But just keep in mind that not every application uses T5 linear. For example, in residential applications, you rarely use that. There are other criteria, CRI, which defines what we call today quality of light. CCT, if we can get warm light that we are used to from an incandescent source. And control, if we can dim it, and what happens to the lifetime when we dim it, and if we can interface with an intelligent control system in the future or not, which will be the future of lighting. Environmental concerns, mercury, lead, and if it has UV coming out of it, certain applications such as food display care about this, and other applications such as retail display also care about this. So this is just a chart and that compares why LED lamp has advantages over linear fluorescent as well as compact fluorescent lamp. Other effects, of course, environmental, for example, with the CFLs. Here, this is a warning label, and here you can see that if a CFL breaks, it advises you to evacuate the room, taking care not to step on the glass shards. And then it tells you how to clean it up. Of course, if you have evacuated the room, it is hard to clean it up afterwards, but you can see the warning label. And in Taiwan, that's in 2010, we actually spent about 150 million NT dollars to provide incentives for users, consumers, to properly dispose of compact fluorescent lamps. With LED, this money could have been saved, and perhaps this amount should be used to incentivize consumers to buy more LED products as opposed to return the environmentally hazardous bulbs. The first product to penetrate the market, I believe it will be the light bulb. Why do I believe that? Because it is very easy to use. If it is designed properly, you can just screw it in. For a consumer, it is the easiest way to adapt it. When solid-state lighting first started, we saw a lot of products by fixture manufacturers where LED was integrated inside the fixture. For example, you can purchase downlights that you replace your whole downlight and the LED is integrated inside the downlight. You can see troffers where you buy a troffer. It comes with the LED and the light source. You cannot change the LED. But recently, if you follow the press, some of the largest lighting companies in the world announced they will actually start selling light bulbs. Well, I don't know how a lighting company will become a light bulb sales company, but this is their choice. But this tells me that a replacement bulb is a better choice, at least in the short term. We can all argue if it takes advantage of LED's benefits or not. Yes, in the long term, the whole source will change, but in the short term, it is the light bulb. This is an example of a LED light fixture being marketed by a lighting company in the US. If you look at the catalog, you will see that it is actually a traditional light fixture. They are just shipping qualified LED replacement bulbs with the fixture. And this is sold as LED fixture. So my point is replacement bulbs will be the initial adoption. And so that's why I care how we can, the manufacturers can sell more of these, how we can penetrate the market quicker. So that's the remainder of my talk. I showed this slide before, but I want to remind everybody that let's consider a 60 watt replacement bulb because 60 watt is the most popular. There are many bulbs out there with 450 lumens, you can replace 40 watt, but the key is how to replace a 60 watt bulb. And you require about 800 lumens to claim equivalency. If you plot, if you assume a driver loss of 15%, a thermal loss of 15%, optical loss of 10%, because a bulb only has a diffuser, not much optical loss perhaps. And if you calculate, because the target is fixed at 800 lumen, and if you calculate LED lumen per watt versus energy savings, about 80 lumen per watt warm light, you start hitting a plateau. And if you go from 80 to 100, your energy savings don't go up as much as if you had gone from, say, 40 to 80 or 60 to 80. Now, increasing the efficacy of the LED has other benefits. For example, you can decrease the size of your heat sink, which would affect the cost of your bulb. That is true. But my point here is, today, we have 100 lumen per watt warm light LED available. And that's pretty much is good enough to make a light bulb and realize most of the savings compared to an incandescent bulb. Because about 100 lumen per watt, you have reached where the plateau is flat. So this is a chart from Navigan Consulting. It was done for Department of Energy 2010. And what I argue here is that if we have the technology today from a component perspective, then what is next? My argument is, for certain applications such as 60 watt light bulb, we have the lumen per watt, we have the performance, but we need to be concerned with lumen per dollar. And if you look at here, what this chart shows is, if you calculate a year's payback from a consumer perspective, what the adoption would be, and it argues if we are less than 2 years payback, then adoption can reach about 50%. So let's calculate how much the bulb should cost to have less than 2 year payback. And this just shows US and Europe energy rates for consumers and industrial and commercial. Based on these rates that are shown here, I do a very simple payback calculation. I actually even ignore the incandescent bulb replacement cost because it is so inexpensive today. And we find that a simple payback calculation says that if you are under 12 euro, or if you are under $10, about $7 US retail price, then the adoption can reach 50%. And this is what we want. So essentially, the target for LED bulb manufacturers like me is, how can I deliver 800 lumen at less than $10 US retail? So this shows, this is from McKinsey Consulting study, and it essentially says that how can we reach parity with CFL and at what time frame? And in this study, they said that if we assume 20% cost reduction year over year, but if we put a sudden 30% cost reduction on the LED cost, then we could reach CFL parity 2 years earlier than otherwise would have been expected. And that puts us about 2013, 2014 timeframe. Is this realistic? Well, this effect is realistic. We can confirm that because some of the major retailers of LED bulbs report that when they decrease the cost of the bulb or the retail price of the bulb by about 25 to 35%, in the same period, they saw sales jump 100%. This is and the jump was sudden, immediate. So this is an indication that how sensitive the bulb price is to the penetration rate. So how can we, now one point is of course LED is about 35 to 40% of the system cost, so if we can reduce the LED component cost, then we can impact the system cost quite a bit. So how can we reduce the LED cost? As you know, nowadays there has been a very fast price erosion in LEDs. One of the reasons is the investment that was made for TFT backlighting. Most of that capacity didn't get fully utilized, so many vertically integrated TV companies diverted that capacity to lighting and started to flood the market with lighting components, which drove the cost down very rapidly. Other applications are automotive and consumer electronics. Why are these important? They may not have the volumes of, say, mobile, but the equipment investment that was made for these applications long years ago have already been amortized. So you actually have an equipment there you don't amortize, but you can apply those LEDs to lighting. So these are the reasons why the price came down or can come down very rapidly. So if you look today, where are we today? A warm white LED, CRI about 80, today you can reach 300 to 400 lumen per dollar. I actually have heard 500 lumen per dollar today, warm white. For cool white, because it is a bit more efficient, you can reach 450 to 500 lumen per dollar. It's actually what happened here, and these are market prices. Yes, these are high volume prices, but these are real prices. So what happened today is, if you look at US Department of Energy predictions, the 500 lumen per dollar or 400 lumen per dollar for warm white has been achieved several years earlier than what they predicted, maybe 2 or 3 years earlier. So given this, I believe we'll be able to reach less than $10 for a 800 lumen bulb in 2013 comfortably. Now, what to expect in the shops? In many parts of the world, such as in the US and Europe, holiday season is coming. It's the Christmas time, and you will see in Europe a light bulb, and it's an A bulb, warm white, nice color, about 300 lumen minimum. So it is not even a 40 watt replacement, which would require 450. Well, this bulb has a little less lumen than that. But, and the price, the lifetime is not 50,000 hours, it's only 15,000 hours. Why not? If the price is right, if you get the payback, why do you care if it's 50 or 60,000 hours? What matters is your warranty period. This will retail at 550 US. It's about 399 euro in Europe. So this is a pretty good price. And consumer affordable 60 watt incandescent replacement, I believe you will see that in 2013. It will have 800 lumen minimum, 2700 Kelvin 80 CRI. It will be dimmable, and it will be less than 10 US dollars. So this is probably will happen, or is going to happen, 2 to 3 years earlier than what we predict. But the question is this: if I sell this bulb at this price, will I make money? I think a lot of the bulb manufacturers are asking themselves the same question right now. What are the challenges facing LED retrofit bulb manufacturers? Well, brand recognition. Like the previous talk mentioned, there are many bulb manufacturers today. They have the know-how, very good, but they don't have the channel. So channel is a big issue. What do? They try to ODM the bulb. But it's very hard to make money when you ODM the bulb because you run into margin stacking. You have to make money, then the brand owner will have to make money. So they are in this dilemma. They want to sell the bulb, they don't have a brand. Should they go build a brand, which will take them 2 to 3 years at a minimum, if they are successful. So credibility and differentiation, if you look at a trade show, you will see that almost everybody has an A bulb. So what is the difference between one manufacturer and the other? And profitability is a big issue. As the prices come down, how will the manufacturers make money? So, on that note, I wanted to show you this chart. Essentially what this chart shows is national LED policy worldwide. I picked Japan, Korea, and China. Essentially what you see is that there are 2 trends here. One, governments set product standards so that consumer confidence increase, and governments allocate funds to provide incentives to convince the consumers to buy LED bulbs. And the amounts are written here. These I'm sure will be available in the printouts, but you can see that there are different programs, EcoPoint in Japan, 15, 30, 20, 60 plan in Korea, which means LED penetration rate reaches 30% in 2015 and 60% in 2020. The government funds here and action and incentives. So in Taiwan, we need this too. As a conclusion, I can summarize, LED lighting products have reached a level where they can replace other energy efficient technologies. So we have the performance. Component cost is coming down, so pretty soon we will have the price. But profitability is a significant issue. And without profitability, then no one will make LED bulbs for the long term. So we need government programs. They are necessary to accelerate solid-state lighting penetration. It's happening all around the world. I believe it is needed in this country as well. Number 1, establish product standards to increase consumer confidence. Number 2, provide resources to encourage consumer purchasing of LED lighting products. And have some sort of legislation, maybe tax breaks, maybe other type of legislation where buildings are checked if they are green or not, and they are required to use a certain, in certain applications, LED lighting only. And this concludes my talk. Thank you very much for your attention.